Causal inference is the process of drawing a conclusion about a causal connection based on the conditions of the occurrence of an effect. The main difference between causal inference and inference of association is that the former analyzes the response of the effect variable when the cause is changed. The science of why things occur is called etiology. Definition: inferring the cause of something has been described as reasoning to the conclusion that something is, or is likely to be, the cause of something else. Identification of the cause or causes of a phenomenon, by establishing covariation of cause and effect, a time-order relationship with the cause preceding the effect, and the elimination of plausible alternative causes. Methods: epidemiological studies employ different epidemiological methods of collecting and measuring evidence of risk factors and effects and different ways of measuring association between the two. A hypothesis is formulated, and then tested with statistical methods. It is statistical inference that helps decide if data are due to chance, also called random variation, or indeed correlated, and if so, how strongly. Common frameworks for causal inference are structural equation modeling and the Rubin causal model. In epidemiology, epidemiology studies patterns of health and disease in defined populations of living beings, in order to infer causes and effects. An association between an exposure to a putative risk factor and a disease may be suggestive of, but is not equivalent to causality, or correlation does not imply causation. Historically, Koch's postulates have been used since the 19th century to decide if a microorganism was the cause of a disease. In the 20th century, the Bradford-Hill criteria, described in 1965, have been used to assess causality of variables outside microbiology. Although even these criteria are not exclusive ways to determine causality. In molecular epidemiology, the phenomena studied are on a molecular biology level, including genetics, where biomarkers are evidence of cause or effects. A recent trend is to identify evidence for influence of the exposure on molecular pathology within diseased tissue or cells. In the emerging interdisciplinary field of molecular pathological epidemiology, third-party source needed, linking the exposure to molecular pathologic signatures of the disease can help to assess causality. Third-party source needed, considering the inherent nature of heterogeneity of a given disease. The unique disease principle, disease phenotyping and subtyping are trends in biomedical and public health sciences, exemplified as personalized medicine and precision medicine. Third-party source needed in computer science. Determination of cause and effect from joint observational data for two-time independent variables, say x and y, has been tackled using asymmetry between evidence for some model in the directions x, y and yx. One idea is to incorporate an independent noise term in the model to compare the evidences of the two directions. Here are some of the noise models for the hypothesis yx with the noise E: additive noise, linear noise, post-nonlinear, heteroscedastic noise, functional noise. The common assumption in these models are, there are no other causes of y, x and E have no common causes. Distribution of causes independent from causal mechanisms. On an intuitive level, the idea is that the factorization of the joint distribution P into P*P typically yields models of lower total complexity than the factorization into P*P. Although the notion of complexity is intuitively appealing, it is not obvious how it should be precisely defined. Education. Graduate courses on causal inferences have been introduced to the curriculum of many schools. Karolinska Institutet, Department of Medical Epidemiology and Biostatistics. University of Groningen, Department of Statistics and Measurement Theory. Harvard University, School of Public Health. University of California, Los Angeles, Department of Epidemiology and Department of Computer Science. McGill University, Department of Epidemiology, Biostatistics and Occupational Health. The University of British Columbia, School of Population and Public Health.